Dear physics aspirants, right now I have the solenoid and the toroid. You will see here the solenoid and the toroid are two pieces of equipment which generate magnetic fields. So you will see here the A and B. A, the magnetic field due to section of the solenoid which has been stretched out for clarity. One only the exterior semicircular part is shown. Notice how the circular loop between neighboring turns tend to cancel. You will see here the magnetic field of a finite solenoid. You will see here the solenoid and the toroid are two pieces of equipment which generate magnetic fields. The television uses the solenoid to generate magnetic fields needed. The synchrotron uses a combination of both to generate the high magnetic fields required in both solenoid and toroid. We come across a situation of high symmetry where Ampere's law can be conveniently applied. Ampere's law. The figure is here. André Ampère 1775-1883. André Marie Ampère was a French physicist, mathematician and chemist who founded the science of electrodynamics. Ampère was a child prodigy who mastered advanced mathematics by the age of 12. Ampère grasped the significance of Oersted discovery. He carried out a large series of experiments to explore the relationship between current, electricity and magnetism. These investigations culminated in 1827 with the publication of the mathematical theory of electrodynamics phenomena, deduced solely from experiments. He hypothesized that all magnetic phenomena are due to circulating electric currents. Ampere was humble and absent-minded. He once forgot an invitation to dine with the Emperor Napoleon. He died of pneumonia at the age of 61. His gravestone bears the epitaph Tandem Felix Happy Last. You will see Andre Ampere here. Dear students and aspirants of physics, you will see here we shall discuss a long solenoid. By long solenoid we mean that the solenoid's length is large compared to its radius. It consists of a long wire wound in the form of a helix where the neighboring turns are closely spaced, so each turn can be regarded as a circular loop. The net magnetic field is the vector sum of the fields due to all the turns. Enameled wires are used for winding so that turns are insulated from each other. Enameled, you know, the varnish enameled wires, so that turns are insulated from each other. Insulation is very important for the coiling. So without insulation it cannot be do the greater efficient level. Figure 417 displays the magnetic fields line for the finite solenoid. We show a section of this solenoid is an enlarged manner of figure 417. You will see here two figures have been given, 417a and 417a. It is clear from the circular loops that the field between two neighboring turns vanishes. Vanishes means not showing, and in figure 417b we see that the fields are filled at the interior midpoint P is uniform, strong and along with the axis and of the solenoid. You will see here with the example of P is here. Strong and along the axis of the solenoid, and the field at the exterior midpoint Q is weak and moreover is along the axis of the solenoid with no perpendicular or normal component. As the solenoid is made longer, it appears like a long cylindrical metal sheet. Figure 418 represents this idealized picture. The field outside the solenoid approaches zero. We shall assume that the field outside is zero. The field inside becomes everywhere parallel to the axis. Parallel. 418, the magnetic field is very long solenoid. We consider a rectangular Amperian loop. As you see the ABCD is to determine the field. Consider rectangular Amperian loop ABCD along the field is 0 and are argued above. Along transverse sections B and AD, the field component is 0. Thus, these two sections make no contribution. Let the field along BAB BE ABB B. Thus, the relevant length of the Amperian loop is L is equal to H. Let N be the number of turns per unit length. Then the total number of turns is NH, and the enclosed current is I. E is equal to I whole N into H, where I is the current in the solenoid from Ampere's circuital law. 417b. You will see here the equation number is 4.20. The direction of the field is given in the right-handed rule. The solenoid is commonly used to obtain a uniform magnetic field. We shall see in the next chapter that a large field is possible by inserting a soft iron core inside the solenoid. So we will study the toroid in next segment of video. We have discussed the physics book. Topic is moving charges, and magnetism and solenoid is a subtopic. So we will meet with a lots of discussions in the next video. Till then, thank you. Thanks for watching the video. Thank you.